Wolfgang Slany is going actually to show us some of his own exquisite work on Lego style, scratch-inspired yet independent, playful environments, apps, widgets, microworlds, we don't quite know, that can be run on smartphones, and that in a different way than what Brian just did, also addresses the question of who so far has been interested in programming, in coding, and who else could be made to participate in joyful ways, as Brian talks, says in getting initiated in programming. It's another way. So I think the three perspectives are actually quite complementary, and it makes for a very good discussion at the end. So Wolfgang, if you can go soon, you try to limit yourself to half an hour, and then we have a general discussion at the end. I am just filling the blank here. One thing that is important to understand about MOOCs is that at the same time that for the first time, the big universities like Harvard, MIT, Stanford, and MIT are releasing for free the contents, their precious contents that so far they kept for themselves, delivered by the biggest experts in the world themselves. We are in a bind because they couldn't keep their business going if they didn't rethink what the students would gain to come to their campuses. So the bind is that they have to reinvent what education is about. And the way they do it is that they sort of use the rhetoric of constructionism and constructivism, but they don't actually really do it. So it becomes really perverse. We are ready. So this is something also to think about in this discussion at the end. Voilà.
Thank you very much. Good morning. I was very inspired by my previous speakers, Gary and Brian. One thing that Gary mentioned was this example of the 8-year-old Sylvia who programmed her Arduino example with the lights and many other things. I was a little bit amazed. There was one slide at the very end where you showed the C code that she would program to really organize this. So I'll show you today some alternative that is more Scratch-like. We know that Scratch is able, of course, to do this, but my software, which runs entirely on smartphones of all sizes, very small ones up to tablets, is able to do as well. So first, this is a non-commercial, non-profit, free open source software project that was started at a university. Even though some of the material may look very commercial, but that's because we have some designers in our team, which might be a little bit untypical, and also because we get some funding and some support from Google. They like very much that we started doing that on Arduino, but in the meantime we also have iOS versions, iPhone versions, and Windows Phone versions, and also versions for HTML5 based phones. So, well, I hope that Google is still supporting us, but let's see. I will just show you a quick video that Google made for us professionally to promote our software for Google Play for Education. So again, it's a little bit commercial. They're promoting their Google Play for Education platform, but you see also statements from kids and from teachers. And one thing that I want to stress also before I show the video is that my initial motivation was not to go into schools. I was hoping that smartphones would become more and more prevalent in the hands of kids. Yesterday, in the inclusion session, which I chaired, Ken Kahn was presenting one project that he had run in Papua New Guinea, and it was really interesting to see. He came with, I think, 14, one laptop per child, laptops, right, to a rural area with, well, it's a poor, complex area there. And the minister came when he presented this to the school, and there were stories in the newspapers and so on. And at one time he said, well, then we found out that 50% of the students had smartphones. So if you think about Scratch, for instance, many, many years of investing a lot of energy into bringing that out to kids. And if you compare that, for instance, to the prevalence of Nintendo DS PlayStations in the hand of kids, of which 200 millions have been sold in the last years, which are now going to be replaced step by step by smartphones, and you have already billions of smartphones available. This was my initial motivation to really have a big impact. I want to change the world, like you. And I hope to do it. And hardware can go up to a certain level. We are doing a lot with hardware, for instance, Lego robots. But Lego robots are really expensive. Outside of South Korea and Japan, they're almost not affordable for normal families. So we are trying to do cheaper things with Arduino, and also to just empower those kids that already have smartphones to do something meaningful with them. Of course, there are skeptics. There are many skeptics telling us impossible. When I first showed our programming software to the app inventor team, they said, wow, can't believe it that it's possible. If we would have known, we would have done it also in the same way. Or some from the audience saying, well, that doesn't work in schools. I agree, it doesn't work in schools, but it was not intended initially for schools, because the smartphone is a private thing that is available everywhere. If I think about the example from Gary also with the I Love You program written in Logo, you were saying she was sitting in the back of the back room, schoolroom, because there was a computer there. But nowadays, she could do that everywhere, anywhere with our software. So let me just show you this a little bit commercial video from Google, but the second half is not from Google, it's from me, and I will comment what kind of programs can be done with it, and also how to program it, and also show a little bit the diversity of things. I have to explain that later, but let me just show it.
My name is Wolfgang Slany. I'm the head of the Catrobot team at Graz University of Technology. We developed Pocket Code, which you can find on Google Play for Education.
That's the commercial part.
We have been looking to getting students more acquainted to tablets. I really love the idea, and the students' reaction was very positive.
Pocket Code is a programming language for children that allows them to create applications, games, and animations for their smartphones and tablets. Google Play for Education has enabled us to get Pocket Code into schools and one click away from educating students.
I think it's important because it gives them the opportunity to take a look behind the scenes. Normally they're only used to consume programs. They don't care how programs are created.
I just painted over
You just painted over the old, I have to admit, and you have to live with this as a teacher, especially in technology classes. that it's not only the students that learn from you, but you also learn from the students.
I made a memory game where you can learn like easy Spanish phrases.
Last lesson, I've created an interactive map of Europe. So if you tap on a country, it tells the country's name in Spanish.
The real benefit is that they can use it everywhere in school. In science and math classes, in language classes, you can use the mobile devices to record voices. So you can have the students get together in groups, practice pronunciation, and you can take it wherever you want.
You can make it move in different directions.
I think the role of mobile devices will definitely increase. They're easy to handle, they're small, they're easy to carry. I think they have a future in our school.
Okay, so that's the second part now. Pocket Code, that's the name of it. It's available on Google Play, also freely available. Here is a small program that was made by a nerd on Scratch, and we just translated it to Pocket Code. Actually, it's with music. Of course, it's non-interactive, but I'm sure she spent hours and hours in creating this animation. And the interesting point is in the scripts, which are very similar, you will see later, to Scratch. There are all kinds of elements like broadcast, variables, and so on. Here I show shortly also the other example that was in the video. So that's just to show you the performance. One of the differences here is that we can use the full resolution of the screens, which can be very, very high. Some of the tablets here have 1920 times 1200 dots, and this can be all taken advantage. Our software is intended for teenagers at the moment. We concentrate on teenagers for various reasons, because, for instance, the motivation issue is too complex for us to handle. Here is an example where kids can, for instance, animate a proof, and then, of course, they learn much better how this proof works than if they would just learn the proof itself without the content. So here's another example, just to show you very quickly. We have also our own painting program necessary because we need transparent, which is also already very complex. We crop the needle, we make a compass here. One of my favorite examples, because everyone understands it immediately and it's very quick to do it. It takes less than a minute. So you have to point the needle in the right direction and do this forever, all the time. So you see, it's very similar to Scratch, but there are a few differences. For instance, we have lots of sensors that can be used. And then, well, the compass works in a few seconds, and then it can also be uploaded to the internet, shared with others. So if you press here the button on upload, then it's possible to share it to the community. And we have our own community where kids can download programs that others have made. And of course, everything is already prepared for remixing. We are really following here the lead of, oops, stop that. We want kids to learn from each other, to share, to remix. So our software is very much modeled after Scratch. Reason is I like Scratch very much, but I want to bring it to a broader audience, simply because I believe that on a worldwide scale, especially in Africa, Southeast Asia, South America, and such places, kids will have smartphones much earlier and much more readily than tablets or PCs. So I have brought many small robots and other things, like for instance this Bluetooth Arduino, which I will also shortly show on the video because it's so small, it's easier to show on the video. In the afternoon I have a workshop. There you can also try out all those things yourself. So just to show you the Arduino stuff, because it's so small, I want to show you this. It also allows to take advantage of NFC technology, near field communication, which is also kind of interesting for various reasons. One of the things that can be done with this version of Pocket Code is that it's possible to very, very quickly make rapid prototyping with NFC technology. And for instance, link some NFC-enabled book or ID card or anything with some physical objects through Arduino. So here you see set Arduino pin 1 to high, and we also have the sensors so it's really interactive. We can control hardware. We can also read out sensor values. And here in this case, for instance, when I touch the phone with a certain book that contains such an NFC tag, there will be a small LED that will be turned on. So here you see the book, and this turns on the LED. And of course, you can do any kind of thing with this technology. So at this moment, I want to go up to the interactive part of my So I prepared another beamer because I need an HDMI connector. Let's see if it works. So I'll project directly from the phone now, and I will show you a few new versions of Pocket Code. So here you see the screen of my phone, and I have many variants prepared. I just have 10 minutes, so let me show you a few of the things that can be done here. One thing that is interesting is you see this tic-tac-toe master here. That's a program that we have transformed into a real Android app. So that's also possible. That's actually normally it would be just a program written on Pocket Code, but now it's possible to play it as an Android. We don't want to emphasize that, but it's just another way to motivate kids to try to write their own programs here. So one thing that I want to show you, there will be very soon now a version of Pocket Code that also includes a physics engine in order to make it more interesting for kids. I know, of course, it's also possible to program your own physics program just by the calculations, but I want to show you how easy it is to create here a new program. So, I make a new object. I have to press on the plus here, and I draw some rectangle to make it quick. So, and then I quickly crop the image and go back to save it. Actually, we want, of course, to improve the usability still a bit. So we have some special move commands that allow to declare this object as physical objects that are bound to gravity. And then, let's say I want to let it bounce from the walls. So I need the if on edge bounce brick. And then to make it a little bit more interesting, I want to turn it a little bit at the beginning. So let's see how this works. Yeah? So this is the possibility that one gets here. And there are special tricks, for instance, to yeah, to detect collisions, for instance. When I detect a collision with another object, something should happen, and so on. So some of the other things that I want to show you is, for instance, one thing that is very interesting is, of course, Lego Mindstorms. We have now a version that not only allows to control all those sensors and motors, but the idea is we conducted in the last years many RoboCup Junior classes with kids, and one of the things that they told us again and again was they wanted to animate the screen. Of course that's possible, but it's really hard, and it's small and in black and white. Now imagine what you can do if you put this here. It becomes very easy to give the robot a face, to let it speak. And one more thing that we have now, and which I want to show you also, is face detection, not recognition. So let me just check whether I have this here installed. Yeah. Sorry, Maureen. To use your image. I hope it still works. Let's see. So what this does is it detects where my face is, based on the movement of my face, and also the size. And by this, of course, if this is here positioned on the Lego Mindstorm robot, and let me just show you the script. That's the whole script. Place at face X position, and here face Y position. And those are here, for instance, the sensors that I've used, this face detected, face size, and so on. So in combination with Lego and other robots, this gives kids already now very interesting possibilities to express themselves. Combined with positioning information, GPS and so on, you could send your Lego robot to your grandmother. And I think that's quite fascinating as well. We have a number of other robots, and one of the most interesting ones is a drone. Yeah? And those of you who know me already, I brought the drone and I'll try to let it fly programmatically. So it's not something that, you know, is only a control of the drone, but really works. Kids can really program the drone, and this drone also includes cameras, so I'll try to film you now on the screen. But for this, I'll have to turn off this screen, the other one. So, I hope it works. Please, everyone, help me, and do not connect yourself to the drone, because of course there are apps to do that, otherwise it will not work. So I have to turn that on again.
It needs a little time.
Yeah, it needs a little bit of time. Anyway, I have to connect it. So, that will be after this will be it. I would have many more things to show, but I'm short. That's not, but it's still 50, right? The whole session.
Yeah.
Okay, so we have 20 minutes. So, let me just press it on here. So, since the drone can also fly like this, but I want to have it a little bit protected because, yeah, it's a dangerous thing. It's starting from the age of 14. So, let me see. Yeah. So the version of the drone that I will try to show you is a little bit an older version. We are working on a new version because there is a new drone that has been published. so it still looks very Android heavy. Oops. And the user interface was done before we had any contact with real designers, so, but the principles are the same. So what you have here is there are all kinds of new bricks that can be used for the drone, like for instance take off or turn on, start a video and such things. So I prepared a small program here which does the following. It makes the screen a little bit bigger, starts the video. Actually I can move that up a little bit. So show that. Then it takes off. After 5 seconds it stops the video and lands again. So I hope it works. Let's try it. And I have to agree to all kinds of disclaimers because, as I said, drones are a little bit dangerous. Yeah? So I hope it works. It's not evident. This is bleeding edge technology. And it has worked in the past. There are some people here who know that it's worked in the past. But it's not always, it's not always working because of various reasons. So this. I try to restart it. I have to first connect it to the drone.